This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part 2 of an introduction to the inverse trig functions. In part 1, we solved equations. And we solved an equation where we were looking for an angle. And that's really the crux of what the inverse trigonometric functions are for. So when we first defined the trig functions, we might have said something like this: the sine of 45 degrees. Now this is a function. We're taking the sine of what? But instead of using like that f of x notation, we just use the word sine, and then we say, this is called the argument, the 45 degrees. The sine of 45 degrees equals what? Well, so then we took the 45 degree angle, if you didn't memorize this yet, which I never do, and that's going to be 1 over square root of 2. Now I know we could rationalize that denominator and write that as square root of 2 over 2. For now I'm just going to leave it like that. So when I was taking the original function, the sine function, sine of 45 degrees, I get a number. Now, the inverse sine is just the opposite. So, the inverse sine function is used to find an angle if you know the sine. And this is what it looks like. Instead of write the sine of 45 degrees equals 1 over the square root of 2, we use this notation. Sine, use a little negative 1. That does not mean 1 over the sine. And what you're saying is what the value of the sine of that angle is. So you're saying the sine of some angle is 1 over square root of 2. So instead, you don't put an angle in here. You're going to put what the sine is, and then you have to say what the angle is that has that sine. You're going backwards. So when you look at the sine inverse, this is how you read this. What's the sine inverse of 1 over square root of 2? You get 45 degrees for your answer. So when you're taking the sine of something, you're putting in an angle in degrees, and the output is a number. When you're doing the sine inverse, you're inputting the number, right? And your output is whatever the angle was. All right, what I have here are the definitions, and I'll explain in a minute why there are these restrictions on the angle in a second. First thing, this is read sine inverse of x, all right? So when you sine that little negative 1, x, it's read as the inverse sine of x. So the negative 1 has nothing to do with reciprocals, okay? And the inverse sine of x, the answer is an angle. So when you compute it, you end up getting an angle, which I'll call a, all right? So here are the definitions. First one, if the sine of a is x and the angle is in between negative 90 degrees and 90 degrees, then the inverse sine of x is equal to a. Now, why do I have it going from negative 90 all the way to 90 instead of just between 0 and 90? Because if you've got the sine being a negative number, it's got to be either in quadrant 2 or quadrant 4. All right, so what we've chosen is quadrant 4, and very specifically, you have to write it as a number, as an angle in between negative 90 degrees and 90 degrees. You can't write 330 degrees, for instance. That might be coterminal with a negative angle, but it's not the same. Now look at the cosine. If the cosine of a is some number, and now look at, and the angle is between 0 degrees and 180 degrees, then the cos inverse of x is that angle. Now again, why did I choose between 0 and 180? Because the cosine is negative in quadrant 2 and 3. So I chose for all the positive values that I'm plugging in for x. I know I'm going to get something in quadrant 1 between 0 and 90, but I've got to choose some place where I might get a negative. And so we go to 180. And the tangent is the same as the sine. It's in between 90 and 90. So here are the very specific definitions, and these are designed so that we have exactly one answer to each problem and that's required for something to be a function. All right, so let's try one of these. Notice it says cosine inverse of -1/2. First of all, this is the inverse of the cosine, which means our answer must be an angle, and it's got to be between 0 and 180 degrees. If it's negative, we must be talking about in quadrant 2. So I can draw a little picture here. -1/2. Now remember, that means the x value has got to be 1, or actually -1, right? Because r is always positive too. So this means I'm looking at this angle right here. Actually, I'll leave this, I'll drop. Let's first just draw the angle. So the angle is right here. Okay, and then you'd have to recognize that as a 30, 60, 90 triangle. Here's where you really have to know your basic 30, 60, 90 triangle, 45, 45, 90 triangle, etc. So in this case, see how you can think of that as -1, 2 square roots of 3. So what is this? We've got 90 plus an extra 30. This has got to be 120 degrees. And there's only one place in between 90 and 180 degrees where you're going to have the cosine being equal to -1/2. All right, let's try another one. All right, now we're looking for the tan inverse of 1, or the inverse tangent of 1. Okay, so you could think of that as 1/1. So this is going to be in quadrant 1. In fact, anytime the number is positive, we're talking about something in quadrant 1. So the y over the x has to be 1. That is the 45-degree angle. So we have 1/1, square roots of 2. So what angle is that? 45 degrees. All right, how about where the inverse cosine of 1, where is that going to be? All right, this is one of those special ones. Anytime you have, if the sine or the cosine is 1 or -1, remember it's on one of the axes. It's one of these 4 points. So you've got to figure out where is it that the x value is 1. And that'll be right here at 1, 0. So that's 0 degrees. Right here, that angle is 0 degrees. And so this is actually equal to 0 degrees. All right, for the problems we've done so far, we have gotten some of the special angles, and that's only going to happen that you can do that without a calculator if you have either something right on the x or y axis, or an angle that is one of the special angles, a multiple of 30 or 45 degrees. So if it's a special angle, you should be able to figure it out. But if it is not, it's not a special value, like I said, the cosine inverse of 0.394, you wouldn't be able to tell what angle that was, and then you could use a calculator. Those functions are in a calculator. One more thing to note is anytime if you're taking the inverse function and you have a positive number in the argument, like cosine inverse of 1 or tan inverse of 1, in other words, not a -1, then you will get an angle in between 0 and 90 degrees. It might be exactly 0 degrees, like in this case, cosine inverse of 1, but you will get something basically in the first quadrant anytime what's in the parentheses here is positive. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.